This video presents content from Chapter 5 of the book Sustainable Living and World Peace, from a section entitled Electronic Device Life Cycle Thinking Example. Now we will consider the life cycle of an electronic device, such as a television, a cell phone, a computer, or a small household appliance. Within an electronic device is a complex arrangement of components composed mostly of metals and plastics. There were probably wastes in the production of the different parts and the final product, and some of the wastes were potentially toxic. Some of the metals used in these products are quite rare in their availability at this time. A lot of energy had to be spent to get the materials together and assemble the device's mechanisms and components in order to create a device with its capabilities. Think of the origin of all the materials, most likely extracted from the earth from around the world. The raw materials had to be transported to a place for refinement, and then the processed materials were transported somewhere to make parts. Most of the parts were probably made in different places and had to be shipped to a location where they could be assembled into a final product. The final product was then shipped to a warehouse and then to a retail center where it could be purchased. Whether it is the electronic device you are considering, a food item, a larger item like a vehicle or building, or any other product, a certain amount of energy was expended in creating the product, which added additional value to the product. In the early stages of production, energy was needed to extract or harvest the materials from the environment, or energy input was required to recover and reprocess the materials if they came from a recycled source. Additional energy was needed for shaping the materials into appropriate parts, assembling the parts into a product, and all the transportation needed to get the materials and parts where they needed to be for the different steps in manufacturing. Every employee that worked on the product had to expend energy to make it to work every day. There were probably steps that involved mechanical motion, heating, and/or cooling, which all involved energy. An item that has as much detail and work-intensive components as an electronic device has a lot of order and organization built up in it. This makes the manufacture of these products quite energy-intensive. All the energy that went into making the product, from obtaining the raw materials, refining or reprocessing the raw materials, reworking the raw materials into components, and then assembling the final product from components, is called embodied energy. The food item we considered had a certain amount of embodied energy, and any processing such as mixing, cooking, refrigerating, and packaging would have added to the amount of embodied energy. The electronic device would have more embodied energy than the food item. This is due to the complexity of the product and its components. We need to consider what it took to obtain the raw materials from the earth, refine and shape the materials, assemble them, and all the associated transportation of all the components and the final product. For both the food item and your electronic device, as well as anything else we purchase or utilize, consider all the potential wastes, some of them toxic, that could have been produced at any step along the production chain. We must also consider all the suppliers of parts and their associated energy use and generated waste. If we were an actual manufacturer trying to make PAL sustainable products, we would have to be clear in our expectations to suppliers of our PAL virtuous ambitions and how we would want the supplies to be made. It might be easier to have control over your own manufacturing facilities than that of our suppliers. However, if their supplies are going into our products, we must ensure they live up to our standards. Too often during a product's end-of-life stage, people in our predominantly disposable thinking society will just throw the old electronic device into the garbage, where it would end up in a landfill. We do this all too often with all other types of products too, not just electronics. Many electronic devices themselves contain toxic chemicals, rare metals, and a lot of embodied energy. If we are willing to just throw these things into a landfill, how certain are we that the toxic materials will not find their way back into the environment? The rare metals would be lost in a landfill and would be unavailable for human use or benefit anymore at that point. All of the embodied energy and all the work that went into making the device would be wasted and lost also. This is definitely a short-sighted way of making, consuming, and disposing of the products we use, and leaves a lot of potential benefits in materials and energy buried in landfills. Even though we can recover and reprocess many of the materials in these devices, or any other consumer product, by recycling them today, recycling technology really is still just in its infancy. However, it is quickly advancing even with current product designs and technology. There are many innovative ways of sorting materials using sensors such as X-rays, spectral imaging, near-infrared sensors, and 3D laser cameras. If potentially used in conjunction with each other, these technologies could sort materials for recovery that would otherwise be quite challenging to do. There is much more that could be done to implement the use of these technologies, and opportunities for advancing recovery and recycling technology are unlimited. Most certainly, progress in recycling, recovery, and reprocessing could occur even faster if we choose to make these things more of a priority. Keep in mind that electronic devices, as well as other products, would be easier to recycle and recover materials from, or reuse components from, if they were originally designed and made with the end-of-life portion of their life cycle in mind. We should design products so that there is little or no waste produced as a result of their manufacture and use. We should design products for disassembly and ease of material recovery while making them highly functional and safe too. Designing products this way will help us make advances in reprocessing materials that are recycled from these products. Since we are considering entire life cycles of products, we also need to make sure the manufacturing and recycling processes do not result in waste or the release of toxic substances as byproducts. By doing all this, you can see that we can conceivably get to where we have created a sustainable product where there is essentially no waste or release of toxic materials into the environment.